Hi class. All right, this recording is for example 3. Example 3, simple direction. Find the domain of each log function. Okay, now remember the domain of an exponential. Let's recap. Domain of exponential is all reals. Okay, and the range was y was greater than 0. That means the domain of log, remember in log it's the inverse of expo. So the domain of log is just going to switch them, right? Log has the domain is going to be greater than 0. So what does that mean? Okay, that means I can't have 0. So how do I do that? I'm just going to take this right here is going to tell us the translation. Okay, so normally the parent, let me go back to basic, f of x equals log base 3 of x. The domain of this one is going to be x has to be greater than 0, because on their last video, if you can see this, okay, says here the domain is a set of positive real numbers. Okay, positive real numbers. That means it has to be bigger than 0. Okay, and the range is a set of all reals. Okay, you don't have to memorize a lot. If you just know that the log function are inverse functions of exponent functions, then you can just go back and jog your memory that way. So the domain of the parent is x is greater than 0, but you have a translation to the right by 2 on example A. Then so as you can see, now the domain is just going to be greater than 2. Or you can take what's here inside of your parentheses, you set it equal to 0, you solve for x normally, so x equals to 2. You make a number line. Okay, remember, the domain cannot be 0, it has to be greater than. So you're going to put a value. So when I pick negative 100, f of negative 100, and plug it back in here, okay, negative 100 minus 2 is now negative. That's not going to be okay. Then we're going to do f of positive 100. That's going to be positive. So your domain is going to be on this side. So how do you write that? You can write domain, okay. You can write x is greater than 2, or you can write non-inclusive 2 all the way to infinity. That's how you find the domain. Okay. Next, same thing over here. You're going to take this and you set equal to 0. X plus 3 over x minus 1 equal to 0. This is a fraction, so the first thing you have to take care is your denominator. X can never ever be 1. Then you solve for it normally. You make this into a fraction, you cross multiply. Then you go, well, x minus 1 times 0 is going to be 0 equals x plus 3 times 1 is now going to be x plus 3. Solve for x equals to negative 3. You have two x values. You need to put it on the number line and test to see which one is going to be positive. Okay, so negative 3 and 1, put them in order. Neither one you can have, so they're going to be open circles. Okay, so this is where you're going to test positive and negative. F of negative 100. Here we go. Negative 100 plus 3 on the top, that's going to be negative. Negative 100 minus 1 is going to be negative. Negative divided by negative is going to be a positive. So keep in mind, just because it's a negative integer doesn't mean you can't have it in log, because negative divided by negative will give you a positive value in here, and that's totally acceptable. Okay. Now, in between negative 3 and 1, I'm going to pick 0. Okay. If I pick 0, on the top is 3, on the bottom is negative 1. That's negative. That's not okay. Then I'm going to pick positive 100, 1,000, whatever value you want to pick, really big. On the top is going to be positive, on the bottom positive, so that's going to give you positive. Okay, so look at this. Your domain is here and here. So how do we write that? We write to, here we go, domain, negative infinity to negative 3 non-inclusive, union that with 1 to infinity. Write it as an interval. It's a lot easier. Okay. Last thing is going to be this, absolute value. It's okay. You're going to take the absolute value, okay? You're going to set it equal to 0. Keep in mind that the absolute value is beautiful, right? Because what happens? Everything you plug in is going to be positive. So remember, we're going to take x minus 1. If this right here isn't 0, I will break it up to two different equations like this, like positive 0 and x minus 1 equals negative 0, right? Remember this? But because 0, there's no positive and negative, I don't have to worry about the negative part of it. So solve for x normally. X can be 1. You're going to plug it in. This is open because remember, the domain of all log function has to be greater than 0, not equal to 0. I'm going to pick some values like negative 100. When I plug it in, negative 100 minus 1, it's going to be negative inside the absolute value. But the absolute value of any number is still going to be positive. And then I'm going to do the same thing to positive 100. Positive 100, it's going to be absolute value positive. Well, it's still going to be positive. So this is unique. It's going to be all real numbers except 1. So we're going to write negative infinity to 1 non-inclusive and 1 to infinity. Or you can write all real number except 1. It's up to you of how you want to write your domain. Okay, so if that is going too fast, go back and listen to it one more time. And this is the end of our recording for example 3.